I've learned so much today, and I want to say thank you to the organisers for inviting me to speak. Um, I don't have a background in engineering, so um, I hope I can still bring something interesting to you today. I have been working in AI now for about 15 years, so hopefully I'll be able to say something. Um, and I hope I can get my slide progress button to work. Let me try there. Okay, there we go. Okay, so first, I'd like to give you a little bit of background on Mind Foundry, who we are, because I'm sure you haven't heard of us, and our work in civil engineering. Uh, so, uh, so Mind Foundry, we're an Oxford University spin out, and we're focused on building trustworthy AI for high stakes sectors. And we were founded by a couple of professors in 2015, and now there's about 100 of us across 3 business units. So it's the most exciting of which I think is the civil infrastructure sector. And over the years, we've done a lot of different work, applying AI in different places for detection, mapping nature risk. But today, I'm going to tell you about what we're doing in civil infrastructure, and in this sector, we're completely focused on solving the problem of managing aging assets. Um, Now, as I said, I'm not an engineer, and so I'm going to, if you excuse me doing so, I'm going to briefly show you a video of some of our important collaborators who can motivate the subject from an industry point of view. So I just hope that this plays.
Our infrastructure is aging, and at the same time we're placing increasing demands and expectations upon it. This is a critical national challenge.
What we need to do as asset managers is to find the right intervention at the right time. And while that might sound simple, in practice it's exceptionally difficult.
That deterioration profile is non-linear. It will go flat and then suddenly accelerate. With AI, we're hoping to predict when the optimal time to do that small maintenance work is, so that we don't have works that cost an order of magnitude more.
And so Mind Foundry and WSP have been working together on this to provide a solution. That's what we call digital custodianship.
Digital custodianship is about building technologies that enable us to look after our bridges, our infrastructure, not just for now, but for the long term.
Denis Gabor, the Hungarian physicist and engineer, once famously said, "We can't predict the future, but we can engineer it." And we see digital custodianship as part of engineering to protect infrastructure for the future.
Thank you for bearing with me on that one. So that's what the experts say. But I can add from my point of view, from my conversations with colleagues, that I think this is a massively overlooked issue. And over the last century, we've built huge numbers of structures, multiple sectors, and often mass investment in specific decades. And so that means that we get structures coming into critical maintenance periods all at the same time. And it's not just a local problem; it's a global problem. And the slide here shows the impact for bridges, but the challenge is also in the water network and national grid, and it's everywhere. What is how do we actually do that? Well, it comes down to some deceptively simple questions: is what do we do, when do we do it, and how do we actually secure the budget to make that happen? And answering those isn't just technical, it's about risk and evidence and making a case that stands up to scrutiny. So this is where we want AI to make a difference. And for AI to make a difference here, is going to need data. Data is always key. So I'm going to talk a bit now about the process of asset management. So it's a complex process. And I'd like to look at where we can bring AI into it. So in bridge asset management, bridges are where we're focused as a company at the moment. Everything starts with visual inspection. Assets are inspected on a strict inspection cycle, and and these result in inspection reports and condition ratings, and this is great practice, but it doesn't create the type of like high quality and objective data that we need for enabling like better data-driven decision making with AI. So, but even though we can't do that decision making in the kind of depth that we want to today, we can use AI for visual inspections. Because AI has become so fantastically successful at computer vision tasks, we can now do things like automatic defect recognition in photographs from visual inspection data. So, yesterday we needed like large labeled data sets to create that capability, but today actually we can get that out of foundation models a lot of the time. Not always, but a lot of the time. And that massively reduces the barrier to bringing AI capabilities in. So the opportunity here is to create tools that enable on-site inspectors to capture visual information, which is really reliable and really consistently aided by this computer vision tools. There are failure modes, which include models failing because they didn't have examples of in their training data, or because the photographs themselves are just not good enough, or perhaps because they've been asked to do something that you wouldn't even be able to do as a human, like distinguish between brickwork and a ceramic facing, which looks like brickwork. But there is, of course, also the risk of adversarial attacks. So, because today we're striving to overcome some of those issues, but looking a bit beyond computer vision, we can do even more with images. We can do objective measurements just directly from images if we have a good thing to calibrate within the image. We can do matching of historical images. That's historically been very difficult to do, but that means that we can start to create time series of measurements of how structures are evolving from the historical record and measure rate of change over time, which is really important. And finally, we can even do some sort of structural calculations. So, well, maybe structural calculations themselves are not there at the moment, and big challenge for the future. But certainly, we can do things like measuring, how far away is a retaining wall, for example, from an ideal plane. So lots of things that we can do today with vision. But as we were hearing from one of the earlier presentations in the session, planning and scheduling, really big. I think it was Paul. Really big part of everything we have to do on structures. Inspection leads to recommendations, and that leads to complicated backlogs that need to be managed and coordinated efficiently to get to keep the structures in service. So today that's mostly manual. People decide what to do and when to do it, and who should be doing it, and that occupies a lot of valuable engineering time. But we think this is a big missed opportunity, and some of our work has we've shown that just automating these kind of planning processes, we can reduce the amount of time spent on the road by 20 to 50%. Let alone the amount of time we save in actually the planning process itself. So that's a lot of valuable engineering headspace freed up. Now that kind of stuff is not powered by some of the AI models you might have heard of. It's powered by other things like graph neural networks or adaptive approaches to optimization. So we're moving outside of that inner circle that you saw Peter show at the beginning of his talk, the LLM circle. It's still highly valuable models. They do have failure modes. All AI systems have failure modes. They're not fully accurate, and so we need to oversee them. But that's actually another opportunity because it allows us to retain the human accountability in the process and keep us in touch with what these tools can do for us. So document processing, again, another thing that I talked about in the earlier presentations. But asset management itself produces a huge amount of documentation, and often it comes down to engineers who are responsible for structures, like sifting through masses of reports to just decide what is the most important thing to do next. And AI can really help with that. Everyone's familiar with GPT models now, but it was when ChatGPT 4 came out with its multimodality, being able to look at both images and text, that suddenly processing of historical documents became possible with just hardly any effort at all. And now we have got the evolution of agentic capabilities, which means models that can be reliably given tasks to do and affect, such as like create me an inspection plan from these 400 pages of inspection history. So that functionality is there today, but actually the assurance of it is not there today. And so verification of these systems is in its infancy, and hallucination is still a big problem in safety critical applications. But there's a lot of momentum behind that. Very interesting research being published this year, looking at how to anticipate hallucinations and how to put verification systems around LLMs. So expect that to move on rapidly as well. Now, how are we putting that into practice? I'd like to tell you a bit about that. Back to this concept of the digital custodian. For us, that's all about digital custodianship. It's like custodianship used to be. We used to have we used to have engineers who were responsible for structures in their local area for almost the whole of their career, and they knew everything about the structure. They could anticipate what was going to happen. Digital custodianship, it's about risk management. It's about doing that in a way which we can apply in an age where we don't have those custodians anymore, those human custodians. So to do that well, we need to improve data gathering, and we need better condition and performance modeling, and also optimized intervention planning. And it's something that operates on different levels. We've got to make sure that the data gathering at an asset level feeds through to analysis and decision making at a portfolio level, and that in turn then feeds back into better interventions, into better intervention decisions at an asset level. Now today we're starting at the beginning of all of it, so we're starting at the visual inspections and trying to provide tools for how to do that, and I can show you here some. This is a mobile app where you can go and take photos, and it will help you make sure that you've got a great photo of the defect and locate it reliably on the structure for you. And down here we've got the desktop application, which allows you to look at things like, what did this defect look like previously, and then measure actually like quantify exactly how much it's changed over time. So we're starting at this level. We're starting with the data, but we're looking ahead to the future as well. And it's all exciting work, and I'm really excited about it. So I just want to, if I can click onto the next slide somehow. Yeah, there we go. Right. So I'm going to leave you with a few thoughts on what I think is coming next, and I'll be echoing some of the things that were said earlier. And for me, it's to go beyond what AI can already do today for civil engineering. We need to develop its ability to incorporate domain knowledge. But that's challenging because we've got to do it in a way that is reliable and trustworthy and verifiable, in fact. Great word. Here are two directions I see it could be really fruitful. So one is integrating domain knowledge actually into the models, so that, in a similar way to traditional finite element model techniques, you know exactly that the model is going to observe some physical laws. You can do that with AI models as well. You just have to architect them in that way. And that seamless be able to do things like really, really well replicate what you can do with finite element models, as you can see here on the Navier-Stokes example. But the second one is the development of actually verifiable reasoning in GPT-like models. Already AI agentic multi-agent systems, they're capable of passing graduate level exams in some subjects, but we can't provide a certificate which says yeah, and they'll always be great at doing this. So that I think is what would really revolutionize the abilities of these types of models and our confidence to deploy them as assistants alongside our engineers. And I do think there is hope that that will be coming soon. So I just end again with a little bit of further reading. I have here got a couple of white papers that we've produced as a company. And I'll just put up here all the references I specifically used for the talk. But thank you. I think